is going to be equivalent to the rate of change. Okay? Rate of change and derivative are the same. Alright? So when you are finding the derivative, you just find f prime of x. Okay, so the rate of change ft at any time of t is given by f prime of a, where a is just a specific value. F prime means gradient. Gradient where x is equal to a. That's what this means. Okay? So the most important thing is just know how to find gradient using rules. Be a master of finding the first derivative. Alright? Now, a positive rate of change is an indicator that the function value will be increasing. You already know that. You already know that if a function is increasing, the gradient will be what? Positive. If the function is decreasing, the gradient will be negative. So we are going to use those concepts. Alright? A negative rate of change is an indicator that the function value is decreasing. This rate of change, it's a gradient. This is a what? Gradient. And that gradient is also the derivative. You don't have to get confused. Rate of change, gradient. Rate of change, derivative. Gradient, derivative. Okay? So make sure you know that. Alright? Can I give you just a few seconds just to copy this down? Alright. Now, Now, the other concept which I told you earlier is the concept of minimum and maximum values. Now, this is very important for you to know. If I draw a cubic graph like that, okay, sometimes you may be asked to determine what is the value of y at the minimum turning point. So you have a value of y here, a value of y there, right? Where we have the turning points, that's where we have a maximum value and a what? Minimum value. Okay? Where we have turning point, that's where we have the maximum and minimum. So, if you look at this function here, this one here, f, that function there, it's quadratic. To the left, the gradient is decreasing. You should know that by now. The gradient is decreasing to the left. The gradient is 0 at the turning point here. The gradient is 0 there. Then to the right, the gradient is increasing, which means the function will be an increasing function because the gradient will be positive. When you're asked to determine the minimum, the minimum value for this case here, all you have to do is find the derivative equated to 0. Then determine whatever value of x is there. Then use that x value to get the actual value of the function. Remember, the value of the function or the minimum value will be a y value. Okay, it's not the x value. But you have to determine the x value first, then you use that to find the minimum value. So the minimum value in this case is reached where the graph starts to increase here, where the graph stops to decrease, which is at the turning point. So you find the derivative equated to 0, solve for what? For x. Then you substitute that x value, or if it's any other variable, you substitute the original function. That's the concept here. Okay? So the minimum value is found where the derivative is equal to 0. Alright? So you can copy that later in your own time. Then the graph, it is at a maximum where you have got a maximum turning point there. At the turning point here, the gradient is what? 0. So if the turning point is the maximum like this, that's where you get the maximum value of the function. Right? To the left of it, the gradient is positive, which means the function is increasing. to the right of this point here, the graph is decreasing because the gradient is negative. Right? I have spoken about that many times. Right? So you get your maximum value when the gradient is 0, which will be a maximum turning point. At the minimum turning point, you get the minimum value. Minimum, yeah, maximum, yeah. Okay. At both points, the gradient is what? 0. At both the minimum turning point, the maximum turning point, the gradient is 0. All right? Right, can I move on to an example of how we are going to apply this? Because most of you are probably asking, what is he going to do with all this? So that's what I'm going to do now. Okay, I'm going to do an example. All right, examples. All right, here I am going to use the fact that, can you stop talking and do me a favor, please? Do me a favor. I need to introduce this quickly. All right, the first example, it says determine the minimum value of f of x equal to x squared minus 6x plus 11. What type of a function is that? It's quadratic. So, if I want to find the minimum value of that quadratic graph, first thing I'll write my function f of x equal to x squared minus 6x plus 11. Right? For it to have a minimum value, it means that must be the turning point, the minimum turning point. So at the minimum turning point, the gradient is what? The gradient is 0 here. Okay? So I have to find f prime of x. That will be 2x minus 6. Okay? I found the derivative using rules. The derivative of that is going to be 2x minus 6. That's the gradient in terms of x at the turning point. Now I need to find the value of x there and also the y value. The y value at that point is the minimum value. But for me to find the y value, I need to determine the x value first. So I will equate this derivative to 0 because it's a turning point. At this point here, the gradient is what? 0. So 2x minus 6 equal to 0. It becomes a grade 8 equation. Then you have 2x equal to 6. Divide both sides by 2. You get x equal to 3. X equal to 3 is not the minimum value. The minimum value is the y value. And for us to get that y value, I have to substitute that x equal to what? To 3. Yeah. So the next thing is to say, I need to substitute it into the original equation. So f3 would be equal to 3 squared minus 6 times 3 plus 11. The final answer that I'll get here is going to be, this is 9 minus 18, that's minus 9. Minus 9 plus 11, that will be positive 2. So the value of y, which is the smallest for that function, is going to be a 2. That 2 there is the minimum value. Always remember that the minimum value or the maximum value is a y value. It's not an x value. Okay? Write it down somewhere in your book. The minimum or maximum value of a function is always the value of y at that point.
So what is
x is the value of x is the value at the stationary or turning point. The minimum value or maximum value of a function. The minimum value or maximum value of a function is always a y value at that point. We don't worry about x. We use the x to determine the y. That y is the minimum or maximum. Okay, let me remind you. Remember, in grade 8 and 9, when you did functions, x was called the input, am I right? And y was called the what? Output. We have the minimum or maximum value is the output. We are not worried about the input. But we have to determine the input first to get the what? Output. Alright? Are you following that? Huh? Alright. Let me go over the next question. Let me go over the next question. Right, the second question, it says, given that p is equal to 4 minus x squared minus 54 over x, determine the value of x for which p is a minimum. Now, in this case, we need to determine the value of x such that p is a minimum, which means we have to find the first derivative, then equate it to what? To 0. Always, when you are doing these questions here, you find the first derivative, then you equate it to 0. You solve for x or for any variable you'll be dealing with. Okay? Then part 2, we have to find the maximum value of p, which is the y value. So for the first part, we are finding x. The second part, we are finding a y value. Okay? So for b1, it will be p is equal to 4 minus x squared minus 54 over x. Right? I want you to put pens down and look here, because what I'm about to do now is extremely important. Put your pen down. Put your pen down. The reason why I'm saying put your pen down, I want all your brain to concentrate on one thing. All right, here we are going to find the derivative. So that division line, this one here, must disappear. Remember, for you to find the derivative, there must be no division lines, no square roots, no brackets. There are three things that must not be there for you to find the derivative. If they are still there and you find the derivative will be wrong. No brackets, no division lines, no square roots. So for me to find the derivative there, I need to remove that division line. So my new function is going to be p equal to 4 minus x squared minus 54x to the power of minus 1. Right? Now, so far, I've been writing, I've been writing f prime of x for the derivative dy over dx. For the first time, I'm going to replace y by another letter. And that letter is a what? P. For the first time, I'm going to replace y with another letter. And in future, we are going to replace y by other letters. Okay? And sometimes we may replace the x by another letter. Okay? So when I write my derivative here, instead of writing it as dy over dx, it's going to be dp over dx. Our function is not y equal to, it's p equal to. Therefore, when I write the derivative, it will be dp over dx. We are trying to find the derivative of p. P is the function in terms of x. So it means instead of writing dy over dx, I'm sure you can see that in the past we used to write y equal to. So this y here has been replaced by what? It has been replaced by p, which means where I used to write dy, I no longer have to write as dy, to be dp. The y has been replaced by p. Okay, every time we normally have that we are dealing with the cubic graph. Here it's not really a cubic graph. Can I have your attention, please? Can I have your attention? Calculus notation is very important. Calculus notation is very important. Alright? So, let's find the derivative. What is the derivative of 4?
0.
Thank you. The derivative of minus x squared? Minus 2x. What is the derivative of the last term there? Plus 54x minus 2. Thank you. Thank you very much. Alright. Now that I found the derivative, I have to equate that derivative to 0 to solve for x. I have to equate the derivative to what? To 0 to solve for x. Okay? So this becomes minus 2x plus 54x to the power of negative 2 equal to 0. You get a mark for equating the derivative to 0. There's 1 mark allocated for that. For equating the derivative to 0, you get what? 1 mark. Right? Okay. Now listen carefully. From that point there, where I wrote the derivative is equal to 0, everything that I'm going to do after that is not grade 12 and it's not calculus, equations, exponents. Okay? That's part of algebra. And that algebra is the one which most of you need to refresh yourself on. If you have got your own tutor somewhere, tell your tutor that my teacher said I must go over the algebra. Okay. I'm not fighting, I'm emphasizing. I'm emphasizing for you to understand that it's very important. Okay? No, I'm not angry. That's how I talk. Especially when I'm emphasizing something that's very important. That's how I talk. Alright, listen, I'm going to repeat that. If you have your own private tutor, you must tell them, my teacher said, I must stop doing all these higher order issues. I need to go to the foundation. Go back to the foundation. Did you hear recently that there's a building in America which fell down in Florida?
Yes.
Yeah. That building is structural issues. You understand? Imagine as we speak. Alright, can you imagine this? Once you are this big mess now, would you imagine that? What would you do? You know what would happen?
I'm not trained for that.
Some will scream yes. Alright, let's get on. Alright. So up to that point then, we have to solve the equation. So this is how you must solve. Right? It becomes minus 2x plus 54x to the power of negative 2 equal to 0. My suggestion here, take the negative 2x to the right. So this becomes 54x to the power of minus 2 equal to 2x. Right? Then the next thing, convert the negative exponent to a positive exponent. Okay? So it will become 54 over x squared. This is equal to 2x. Okay? Are you following that? Now, be aware that the denominator of that 2x is a 1. So we have to cross multiply, right? Cross multiply there. If you cross multiply, you get 54 on the left. On the right, it will be x squared times 2x. That will be 2x cubed. Okay? I hope you are following what I'm doing, because this concept is very important when you are doing questions on application in calculus. Right? Then you divide both sides by 2. So you get 27 on the left and x cubed on the right. Right? Now it's very easy now. Find the cube root of 27. Okay? You get 3. So the final answer will be what? The 3. Are you following that? Hello? Are you following what I just did? So your answer is going to be a positive 3. Now, this is the first part of the question, which is very important. Finding the x value is very important. But for you to find the minimum value of p, you need to get a correct x value first. If the value of x is incorrect, then you won't get a correct value of p. So I've done the first part. Is there anybody else got any question? Anyone who has got any question? But if you don't have a question, then let's move on to find p. Now, the minimum value of p, it means we need the original equation for p. Right? So, number 2, it's p equal to 4 minus it will be minus x squared minus 54 over x squared. Like that. Now, to get the maximum value of p, you must get the x value, okay, the x value first. So I managed to get that x value. The x value that I got, that's the x value for the maximum, okay, for the maximum point. At that maximum point, I'll get the maximum value of p. Remember, for me to get the x value, I had to find the first derivative, then equate it to what? To 0. By finding the first derivative and equating it to 0 and solving for x, I was actually finding the value of x at the maximum point. At that maximum point, there is a y value. And for our case here, it's p. So all I have to do is substitute x where there is x in that equation. Because the x that I'm substituting, it is the x which will give me a maximum value for p. Yes? No, I'm using, oh, so I put x squared, it's supposed to be x. So it's a mistake that I made. Alright. So it doesn't want to be removed. Alright, yeah. So it means this will be p equal to 4 minus 3 squared minus 54 over 3. I'm going to repeat what I said. The x value that I got, which was a 3, it's an x value that will give me the maximum value. Okay? How did I get it? I found the first derivative, equated the first derivative to 0. By finding the first derivative and equating it to 0, I'm actually at a minimum or a maximum turning point. Okay? So, from here, you get 4 minus 9 minus 18. So this give me negative 27 minus 4, that will give me negative 23. So the minimum value of P is gonna, sorry, the maximum value of P rather is gonna be negative 23. Okay? Any question before I move on to another example? This is the maximum value. Yeah, the question was asking for a maximum. So this is the maximum. All right, another example. Now, this type now, that's the most common one, where they give you a shape. Either it can be a quadrilateral, like in this case, we have got a rectangle. You can have the prisms that I told you about. That's why you have to go back, grade 11, grade 10 measurement. Over the weekend, please, you need to do that. All right, so I'm going to do this example. Then we might take a short break for about 5 minutes. When we carry on, so probably around 12 or so, I'm going to release you. Right? I don't want to release you at 12. Around 12 o'clock, I'll release you. All right, so let's look at this question. The question says, the sketch alongside shows a rectangle with a perimeter of 18 meters. Okay, perimeter. Do you remember what perimeter is? Right? Okay, all right. So the perimeter is 80 meters. Let the breadth, which is also called the width, and the length of the rectangle be x and y. So the breadth is x, the length is y. Okay? Now the first question says, show that the area of the rectangle is given by that. Alright, let me be very clear to all of you. The last question of your calculus, this is how it will look like. If you check all the past papers like the ones that I sent you, I hope you are aware that I sent you past papers recently. A past paper booklet with the memo too. Okay? Use that wisely. Alright? So here, the perimeter. What's the formula for the perimeter of a rectangle? It's 2 times L plus B. Right? So, listen. Sorry, can you tell her to pay attention? Pay attention. Sit down and pay attention. Alright. Listen. The perimeter of this rectangle, it will be x plus y plus x plus y. That's the perimeter. But there's a general formula for perimeter. It's 2 times L plus B. So this becomes P equal to 2 times x plus, okay, in this case my length is y, so I'll start with y. My length is y, so it will be y plus x. Eventually, I can write this as 2y plus 2x. So that's my perimeter. Now, when you're doing these questions here, your knowledge of perimeter is required, area is required, volume is required. Surface area is also required. Okay? Alright. Are you following here? Hey, listen. Listen. I need you to answer me. Are you following so far? Yes. Alright, then the next thing that we have to do, right? Because here, for us to get ax equal to 40x minus x squared, it means we need to create this 40 here. Right? To create that 40, this is the root that you must take. You can't say area is equal to LB. then you multiply x and y. X and y is not equal to this. Do you agree with me on that? Why? What's the area of a rectangle? How do you calculate the area of a rectangle? Length times breadth. What's our length here?
Y.
Breadth?
X.
What would be the area in terms of x and y?
Y.
It would be xy. But here our area, does it have y here? No. Which means I need to write y in terms of x.
So isn't it okay equals to y? I'm just asking.
Okay, look here. The formula for our area, does it have y here? It doesn't have y, which means in the original formula for area is equal to xy. I need to replace that y by what? By an expression in terms of x. So that's what I'm going to do first here. So the next thing is I'll substitute this p here by what? 80. So you get 80 equal to 2y plus 2x. Are you following them? Okay. Then can you carry on? Okay, can you please carry on with the work? Stop talking to each other. Then the next thing you factorize on the right. I factorize that. Why am I doing that? I want to create that 40 there. So if I divide both sides by 2, I'll get 40 on the left, and I'll get y plus x on the right. Now I'm smiling. Then the next thing, I just need to make y the subject. Okay? So what this means is, if I take this x to the left, it will be the same as writing y equal to 40 minus what? Minus x. Right? But my area of a rectangle, A, I can write it as AX, because it's in terms of x, is equal to LB, which is equal to XY. Yes, the length is, listen, the length is y, the breadth is x. What is x times y? X times y is xy.
So sir, when you say LB, the table is y.
Yes, because of multiplication. All right. Hey, listen. Can I have your attention? Can I have your attention? Just stop talking, because you lose energy for talking and moving around. Listen, boys and girls. The area of a rectangle is length times breadth. Right? Our breadth here is x. Our length is what? Y. What is x times y? xy. But this formula here, does it have y? No. So I created an equation that will eliminate y. And that equation is this one. You see that equation? I can use it to replace y by x. So my area in terms of x is going to be xy. But what is y equal to in terms of x? Yes, so I can write this as ax equal to x times 40 minus x. Okay? Like that. Are you following that? Yes. I'm replacing y by an expression in terms of x. So this becomes ax equal to 40x minus x squared, which is what we have there. All right, so I have found the the expression which I'm supposed to show that it's equal to that. And then the next thing now is the question says, determine the dimensions of the rectangle for which the area will be a minimum. Okay? Can I have your attention? Now, for me to determine the dimensions, it means I need to find x and y. Okay? Right? I need to find an x and y for the area of the rectangle to be a maximum, which means I have to find the derivative and equate it to 0. Okay? Dimensions means the exact values of x and y. When the area is the maximum, remember I said earlier, in calculus, when you are doing application, we use the concept that at the turning point, we have a maximum value or a minimum value. So if the question is saying, determine the dimensions for the rectangle for which the area will be a maximum, it means find the first derivative and equate it to what? To 0. So whenever you get a question like this, it will say maximum or minimum. The first thing that you must do there, find the derivative, the first derivative, and equate it to what? To 0. Then you solve after that. All right? That's what you're supposed to do during break time. All right. So here, all I have to do is find the derivative of this function. Okay, I'm going to do that on the next page. Make sure you pay attention as I do it. So we have ax equal to 40x minus x squared. I just need to remind everyone that this a here, it has replaced f because we are no longer dealing with a quadratic graph.
So now, A is equal to y.
Yes. Ax is equal to y.
Not only now.
Yes, now under application. Okay? So, what this means is, if I want to find the derivative, I'll write it as a prime of x. Remember, we used to write it as f prime of x. Now, I can also write it using another notation, but at this stage, I don't want to confuse you. I'll talk about it next time. So, a prime of x, it will be the first derivative. It will be equal to, what's the derivative of 40x? 40. The derivative of a constant times a variable is always the constant. You understand that? Then, what's the derivative of minus x squared? It will be minus 2x. Alright? Then, what's the next thing? Equate the derivative to what? 0. So we'll get 40 minus 2x equal to 0. In an example, you will get a mark for finding the derivative and for equating it to 0. Alright? Then, that's a grade 8 equation. Okay? So 40 will be equal to 2x, then you divide both sides by 2, you get 20 equal to x. 20 equal to x means that our breadth is going to be equal to what? To 20 meters. Okay? It's going to be 20 meters. So how do you get x? Sorry, y rather. You go back to this equation. You see this equation here? This one here. You just substitute into that. So simple. You see that? It's not very difficult. Right? So it will be y equal to 40 minus x. So y is equal to 40 minus x. Therefore, 40 minus 20, you get 20. So what this means is that the breadth is 20 meters. The length is also 20 meters. That's what it means. Okay. So I've answered that. I've determined the dimensions of that rectangle. All right. Any question there before I move on to the last one?
Carry on.
Right. The last one. Now, okay.
No, you mentioned y is equal to 40 minus x. Why don't you answer it?
Why? Okay. Why don't I use what?
The square root. No, in green. You said y is equal to 40.
Because I'm trying to find y. Y is the length.
You can take the
Oh, yeah.
No, the original one is for the area. Remember this. Remember. What is AX? AX is the area. AX is the area. Can I have your attention? Can I have your attention? Our variable here, can I have your attention, please? This formula here, that's for the area. Okay? Don't worry. The next part of the question, we are going to find this. We are going to use this equation. We have found the value of x for the area to be a what? A maximum. Right? That value of x is 20. Are you following there? Please don't confuse this question here. You need to find the value of y, which is the length of the rectangle. To find it, you have to use this equation. Okay? Then, the next question now says, calculate the maximum area of the rectangle. Now, this is now where you substitute the value of x, which you got in the previous question. Here into the original. Alright? So, let's move on to part 3. So, part 3, we write ax is equal to 40x minus x squared. Now I'm finding the maximum area. To get it, I need to use the x value, which is the maximum as well. So this will be A20. Remember, our x was what? 20. So it will be A20 is equal to 40 times 20 minus 20 squared. This gives me 800, and that gives me 400. So the final answer will be 400 square meters. Okay? Like that. That will be the answer. Do you have any question before I do the last one and then we go?
No question.
Right, the next question, it involves some measurement, but I chose a very easy question because this is a cylinder. It's not that complicated, but we have got other prisms as well. Right? So, this is a typical examination question. So, question 9 says, can I have your attention? You have got a can, right? Like this. Like this. Right? The volume of the can is 340 square centimeters. This one is 400. Right? A height of 8 centimeters and a radius of r centimeters. Right? Now, 9.1 says express h in terms of r. How do you calculate the volume of a cylinder? Do you still remember?
This is height.
Alright, the volume of a cylinder is V equal to pi r squared h.
I know.
Right? Hey, listen. Can I have your attention, please? Can I have your attention? Hey. You are in class. Okay? So the volume of a cylinder is pi r squared h. But the question says express h in terms of r. What this means is make what? R the subject. Or rather, okay, express h in terms of r means make h the subject rather. Okay, so we need to make this h here the subject. But what's the volume given here? It's what? 340. So where there is B, we put 340 there, and we get equal to pi r squared h. We need to express h in terms of r. Therefore, I can write this as pi r squared h is equal to 340. Then the next thing is to divide both sides by what? Pi r squared. Because we want to write h in terms of r. So I have to divide both sides by pi r squared. In the end, my final answer will be h is equal to 340 over pi r squared. Okay? What I just did here is not grade 12, it's not calculus, it's equation measurement. Grade 10, grade 11. Okay? Grade 10, grade 11 work. Alright? Then the next question now says, 9.2 says, show that the surface area of the cane is given by that. Now here, I just need to explain something. We are going to assume that the cane has both a top and a what? And a bottom. Because there will be two different formulae if you consider a case where there is no top and another case where the top is there. The bottom obviously will always be there. But sometimes you might not have the bottom as well. Alright. So to do 9.2, we need to know what is the formula for covering the surface area of a cylinder. Right? The surface area of a cylinder is very simple. I'll just show it to you now. Just take you to the basics. Right, let's say this is what shape is this? Right, if I fold it like that, right? We are going to have a circle on top and a circle on what? At the bottom. If we assume that both of them are there, like in this question here, how do you calculate the area of a circle? Pi r squared. Right? So 9.2, our surface area, which in this question here, it's denoted by AR. That's our surface area. So I'll say AR is equal to 2 pi r squared, right? Why 2 pi r squared? Because this is pi r squared, that's also pi r squared. So it becomes 2 circles. Then, how do you calculate the area of a rectangle? Okay, we are going to have a height, right? And we also have a perimeter. The perimeter, okay, of a circle is equal to what? How do you calculate the perimeter of a circle? 2 pi r. So this will be 2 pi r h. No, that formula you did it in grade 10. Hey, listen. I don't understand why you can behave like you've never seen that before. You did measurement in grade 9. You did measurement in grade 10. Okay, that's why I'm refreshing you. That's why I'm refreshing you. Okay.
The thing is, this is 2 pi r h is the total.
Yeah, you see, if I start like this, right? This is the length, that's the what? The breadth. But this breadth here, it's equal to h. This height is your h. But if I fold it like this, I'll end up having a circle. How do you calculate the circumference or the perimeter of a circle? 2 pi r. So it will be 2 pi r times the h. Hey, can I have your attention, please? So, all I have to do is replace what? This h here by, replace that by what? By this formula here. Okay, so it will be 340 over pi r squared. So that will be 340 over pi r squared. And this will give me 2 pi r squared plus, now here I can just cancel out some of the terms. So this pi and that pi cancel. Do you agree with me that this r here and one of those two also cancel? So I'm going to be left with 1 r there. Okay? So then 2 times 3/4 will give me 680. 680 over R. Are you following there? Can you do me a favor? Just pay attention just for a few minutes. Are you following there? So this is AR. Then I can remove the division line and write as 2 pi R squared plus 68 R to the power of 1, which is what I was supposed to show. Right? Your homework is to do the last question.